Okay, so there's what we just did. That was on worksheet 1.8, domain number 2, if anyone's watching later. Okay, now we're gonna do the 1-9 inverses. So let's get a new whiteboard screen. How do I do that? Okay, good. And so, you want me to just do 13?
Yeah.
Or start at 13?
Yeah.
Okay, let's get that out. Let me make sure I have the right sheet. Okay, I think it's this one. All right, so when you are trying to tell if they're inverses of each other or not, first let me write them down so everybody has it. Okay. Oh my gosh. This is also my first time using a pen,
Mhm.
like to write on this. So I'm not really good at it yet. Okay, so we have the 5th root of x plus 2. So there's f of x, and then g of x is 2x cubed plus 2. Okay, so when you want to find out if two functions are inverses of each other or not, you're going to do f of g of x, and you also want to do g of f of x. You want to do it both ways, so I'll just put that down here. It doesn't matter which one you do first. Whichever way you do it, when you simplify the answer, it should come out to be just x. So everything cancels out and you're just left with x if they are inverses of each other. If they're not, then it's never going to simplify down to just x. So if I try the first way, f of g of x, so let's take g and put it into the f. So that would look like this. Let me fix that equal sign. That's the 5th root of, now all of g is going to go in there, 2x cubed plus 2, and then I have a plus 2 over here. All right, now there's not much simplifying that you can do on this one. And do you see a way that's going to simplify down to just an x? I sure don't.
No.
Yeah, there's no way that this is going to, there's nothing I can do here. So once I realize that this is not going to get to x, I don't have to bother with this one. Because if it doesn't work one way, it doesn't matter if it works the other way or not. It's already a no. So that guy's a no. Okay, let's try one like 14 that does work, and I'll show you what it looks like when it does work. So let's get a new whiteboard. So here's 14 on that same page. You've got f of x 4 over x plus 1, and then a minus 2. G of x 4 over x plus 2 minus 1. Okay, so we're going to do the same thing. G of x, g of f of x, and f of g of x. Doesn't matter which one you do first. It's up to you. So if I do this one, I'm going to take g and put it into the f. So I'm going to write kind of big so I can fit everything. So take the g and put it into the f. So here's the f. Now instead of the x and the f, I'm going to write everything that the g is. And then continue on with the rest of f. So then there was a plus 1 and then a minus 2 over here. Does that make sense so far?
Yes.
Okay, so now you can see that some things are going to simplify. Like right here, down in that denominator, I have the minus 1 plus 1, so they just cancel each other out.
Mhm.
So I'll have 4 over x plus 2, and then a minus 2. So far, so good?
Yes.
Now, that first fraction, right? Another way to rewrite that, couldn't I do it? Remember keep, change, flip?
Yeah.
Let's keep the numerator, change to multiplication, and then flip the denominator. So if I do that, watch what happens now. So let's keep the 4, change to multiplication, and then flip my denominator, x plus 2 over 4. And then I have that minus 2. So now what happens is that those 4s are going to cancel. And now I have x plus 2 minus 2. So now the 2's just cancel. So I really am just left with x. So now I'm like, okay, cool. So doing the f of g of x worked. Oh, geez. I thought I said, hey, Google. So now it's like talking to me. How do I? No. Okay. All right. Now we just have to try it the other way and make sure that the other way also ends up being just x. So how can I haven't figured out how to erase just part of the screen. Well, that kind of works. Okay. Okay, now let's do g of f of x. Okay, so let's take the f and put it in the g. Oops. Oops. What's happening? Oh no. Uh-oh. Sorry, I think my pen just freaked out on me.
It's okay.
All right, where was I? X plus 1. I was putting the f in the g, and I think I messed up. That's supposed to be a minus, isn't it? X plus 1 minus 2, and then plus 2 minus 1. Okay, so there's f into g. Do you agree?
Mhm.
So basically the same thing's going to happen. Those 2's are going to cancel. And now I'll do cube change flip. So I'll have 4 times x plus 1 over 4. And then minus the 1. 4's cancel. And then the minus 1 plus 1 cancel. And I'm just left with x. So that means that, yes, these are inverses of each other. Does that make sense?
Yeah.
And once you realize that it's not going to work, you don't have to keep going. So even, I don't know, do you want me to do 15?
Yeah.
Okay, so let's get a new whiteboard. So 15 is g of x out to cube root x minus 2 over 2. And then f of x negative x plus 1 to the 5th. Okay, so let's go ahead and pop them in, so it doesn't even matter which way you do it. Well, I'll just do g of f of x first. So take the f and put it into the g. So I'll have a big old cube root. And then instead of that x, I'm going to write negative x plus 1 to the 5th minus 2 all over 2. Okay, so one thing that I kind of like to do is just look at the x's. This x inside that parenthesis, right? Eventually, it's going to be raised to the 5th power. If I have x to the 5th power and I take the cube root of it, it still doesn't get me just x, right? Let alone there's all these other numbers that I don't even know what's going to happen with them, but that's never going to simplify down to just x. So even if all the numbers, the 1 and the negative 2 and the positive 2, if those somehow miraculously cancel out, it doesn't matter because I'm not going to have x to the 1st power anyway. So there's no need to really go any further. This can't just boil down to just be x. Does that make sense?
Yeah.
Okay, yeah. So I wouldn't even go any further because I would just say no.
Okay.
I mean, you could try if you had done f of g first, let's just say. So let's put the g in the f. Just making sure I copied this right. X, yeah. Okay, and then a +1 to the 5th. All right, so same thing. On the inside, I have a cube root of x, and I'm going to raise it to the 5th power. That's never going to boil down to just be x. So
Okay.
I'm not even worried about what's even going to happen with all the other numbers. I can't go anywhere, so this one's a no. When it's a yes, like things you'll just see, they all just kind of fall away. They cancel out really nicely.
Okay.
And yeah, when it's just a disaster like this, there's nowhere to go. So it's a no. Yep. Okay. Any other ones I can do for you?
Um, on the homework from 318, can you go over number 10?
Yes. Let me get that up. 318. That's the domain number 1?
Yeah.
Okay. Let me get this up. So I don't have numbers. What does it say?
It says h of x divided by f of x.
Oh, okay, the very last one?
Yeah.
Okay. All right, so let's do new whiteboard. Okay, so we need h of x is 1 over x plus 1 f of x. Okay, so the problem is asking us to do h of x over f of x and then state the domain. Okay, so we have to do h of x 1 over x plus 1 all over f of x plus 3. Okay, so first of all, I don't want to leave it as a fraction and a fraction. So I'm going to rewrite this doing that same keep, change, flip. I'll keep the numerator, change the multiplication, and I'll flip the denominator. So now my function, if I kind of put that together, looks like this. 1 over x plus 1 times the square root of x plus 3. Okay, is that all right so far?
Yeah.
Okay, so there's my answer for that first line. There's h of x over f of x. So now I have to talk about the domain, right? So remember the two things that I can't have in my domain. I can't have a 0 in the denominator, and if I have a square root anywhere in the problem, it can't go negative. So I have both of those situations going on. So for that x plus 1, I can't have a -1, right? Because that would get me a 0 in the denominator. So we know we cannot have -1. That's out. Then I have this square root of x plus 3 business. Well, it's a square root, so I can't let it go negative. But since it's a square root in the denominator, not only can I not let it go negative, I'm not allowed to let it equal 0 either. So because normally if it was just a square root, I would say, okay, whatever x plus 3 is has to be greater than or equal to 0. But in this case, because it's in the denominator, it's not allowed to equal 0 either. It just has to be greater than 0. Does that make sense?
Yeah.
So now if I solve that one, x has to be greater than -3. Okay, so what I need to do is I need to put these together to make one domain for the whole thing. Okay, so you could leave it like that, or if you're going to do it in interval notation, basically, if you take a look at a number line, right, and I have -3 here and I have -1 here. So for the first thing, I'm not allowed to have -1. Oh, let's change colors. Let's do green. I can have everything except for -1. So that would be an open dot at -1 with arrows going forever. Right? So there's a graph of x cannot equal -1. Now I'm going to graph x has to be greater than -3. So if I'm going to graph that, oh, come on. There we go. There's x has to be greater than -3, right? So my domain for the whole problem is wherever these two overlap each other. In other words, where does it work for both of them? So it does not work for both of them at -3. It only works for green, not blue. But once I get greater than -3, it does work for everybody. So I'm going to start at -3. And then it continues to work for everybody, work for everybody, work for everybody until I hit -1. At -1, it doesn't work for everybody. So I have to make a jump there. But then once I get past -1, it works for everybody forever. So that would be my domain for the whole thing. And you can test these values, right? So you can try, like if I look at the number line here, plug in -4, it's gonna make this over here, it's gonna make it break somewhere, right? If I plug in -4, there's no problem with the x plus 1 part, but if you plug in -4 under that square root, -4 plus 3 is now -1, and you can't take the square root of -1 in the real number system. So it's broken. Whereas if I try and plug in a number between -3 and -1, right? So if I plug in -2, it should work just fine. And it does. If you plug in -2 underneath that square root, -2 plus 3 is a +1, and you can take the square root of that. And I have no problems. It's not going to make the other thing 0. So -2 is just fine. So I always think it's very important, if you're not great at these domain things, once you have what you think is right, check some values in those intervals and make sure that they work or don't work like you expect them to. Does that make sense?
Okay. Yeah.
Okay. All right. I'll just keep checking if anybody else is coming, but I guess not. That's fine. All right. What else can I do for you?
Um, could you go over on the same worksheet, the h of x minus the f of x, the one that's like above the last one we just did?
Oh, yeah, sure. Okay. So let me erase this stuff. I don't know if there's a more efficient way, but whatever. I'm sure there is. Okay. So we want to do h of x minus f of x. Okay, so let's plug that in. H of x, 1 over x plus 1. And we want to subtract the square root of x plus 3. So there's h of x minus f of x. Okay, so there's that. And now the two things that I worry about. Do I have a variable in the denominator? Yes, I do. Right here, the x plus 1. So I can't ever let that x lead me to a 0 in the denominator. And then I do have a square root, so I'm never allowed to let that thing go negative. So first thing I notice is with this guy, I'm not allowed to have -1 because then he breaks. So I know that that's not allowed to equal -1. Then I take a look over here at the square root thing. That is never allowed to be negative. Now, in the last problem, I wasn't allowed to let it equal 0 either because it was in the denominator. But this guy's not in the denominator, so I don't care if he's 0. He just can't be negative. So that means whatever I pop in for x plus 3 has to be greater than or equal to 0. Okay, but it can equal 0 this time just because it's not in a denominator, so it doesn't matter. So now let's solve this one. -3 minus 3. So now it's these two I need to put together. So I can have anything greater than or equal to -3 as long as it's not 1. So if you do a quick number line, -3 and a +1, I'd have, I can't have -1. And then for the other one, I can have anything greater than or equal to -3. So that would be filled in there this way. So now I just want who works for both. So let's, okay. So I can have -3, so I'd start with a closed bracket. And I can have it up to +1, but then I have to jump over it. And that's it.
Awesome.
Does that make sense?
Yeah.
Okay, cool. All right. Any other ones?
I think I'm good.
Yeah?
Yeah.
Okay, awesome. Well, thank you for coming. Otherwise, I would have been really
Yeah.
by myself here. All right. Is there anything else I can help you with? How are your other classes?
They're pretty good. Yeah.
Are you getting a lot of work or not really?
Yeah, kind of. For at least for English, it's a lot of work.
Yeah.
But like, but for some of my other classes, it's surprisingly like a little amount, which is just kind of weird. But I don't know.
Yeah. Do you feel like math is an appropriate amount? Do you want more? Do you
Yeah.
want less?
No, I think it's good.
Okay.
Yeah.
It's so
It's,
well, like none of us really know what to do. So we're
yeah.
like trying our best. But anyway, well,
Yeah.
thank you so much for coming and getting
Uh-huh.
up early with me.
Yeah.
Yay! All right. Well, have a good one.
Thanks, you too.
Bye.
Bye.